We've been conditioned to look at the night sky and see a map. Since childhood, pop culture, movies, and science fiction books have sold us a very comforting lie. They convinced us that the Milky Way, with its billions of stars, is just a vast ocean waiting to be navigated. We learned that crossing our own galaxy is simply a matter of time and technology, that all we need to do is build the right engine, engage hyperspace, warp drive, or whatever magical name you prefer, and in a few weeks, we'll be on the other side, founding colonies and building galactic empires. Erase that from your mind. It's an illusion. Our galaxy is not a territory to be conquered. It is a maximum security prison, and the bars of our cell are forged from the very fabric of space and time. In today's video, we're going to do the brutal, raw, real math of exactly how long it would take to cross the Milky Way from one end to the other. We're stripping away the magic of Hollywood and putting the unforgiving laws of physics on the table. And you're going to discover that the problem preventing us from becoming a galactic species isn't that our technology is primitive. The problem is far more terrifying. The problem is that even if you break physics and manage to travel at the absolute speed of light, when your ship finally reaches the other side, the humanity you left behind will no longer exist. To begin understanding the monster we're facing, we first need to fix our ruler. The human brain evolved to calculate distances in kilometers or miles. We understand what it means to walk to the neighboring town, drive across a continent, or even fly over an ocean. But when astronomers say the Milky Way is 100,000 light years in diameter, our brains simply shut down. The number is too large, so we treat it as just another long distance. We need to humble our perception. Let's shrink things down to a scale we can touch. Imagine that our entire solar system, from the boiling sun to the distant, frozen orbit of Neptune, were shrunk down to the exact size of a $1 coin. Place that coin in the palm of your hand. On this imaginary scale, the closest star to our sun, Proxima Centauri, would not be at your fingertip. It would be roughly 100 meters away, the equivalent of an entire soccer field of absolute emptiness between two coins. Now, keeping that same proportion, how large would the entire Milky Way be? If our solar system is a $1 coin, our galaxy would be the size of the entire North American continent. We are microbes living in a single groove of a coin, and we want to cross an entire continent where there are almost no other coins, only freezing and dark emptiness. Let's use our best current technology to attempt this imaginary crossing. The fastest machine human engineering has ever built is NASA's Parker Solar Probe. Using the sun's gravity as a slingshot, it can reach staggering speeds of about 700,000 kilometers per hour. That's unimaginable speed on Earth. You could circle our planet in just minutes. If we placed astronauts in a ship traveling at that exact speed and aimed it toward the opposite side of the Milky Way, the journey would take approximately 1,700,000,000 years. Earth is about 4.5 billion years old. If you went back 1,700,000,000 years into our planet's past, you wouldn't find dinosaurs. You wouldn't find trees, insects, or fish. Life on Earth consisted only of bacteria and microscopic single-celled organisms floating in toxic oceans. The continents didn't even have the shapes we recognize today. If our bacterial ancestors had built a spaceship with our current technology and launched it back then, they would only be arriving at the other side of the galaxy today. Our most advanced technology is, on the cosmic scale, an insect crawling through mud. But of course, someone might argue that technology will evolve, that in the future we won't use primitive rockets. Let's say that in a distant future, humanity unlocks all the secrets of the universe. We master quantum physics, energy manipulation, and build the ultimate ship, one capable of traveling exactly at the speed of light, 300,000 kilometers per second, the absolute speed limit of the universe, dictated by Einstein's own laws. There is no way to go faster without breaking reality itself. We tend to think of light as instantaneous, but in space, light is agonizingly slow. If your perfect ship left Earth today, traveling at 100% of the speed of light, the journey to cross the Milky Way would take exactly 100,000 years. Once again, the numbers deceive us. 100,000 years sounds small compared to a billion, but let's look at our own history. What does 100,000 years mean for the human race? The entirety of human civilization, everything we consider history, is only about 10,000 years old. The invention of agriculture, the construction of the pyramids of Egypt, the Roman Empire, the age of exploration, the Industrial Revolution, the World Wars, and the moon landing. All of it happened in a blink of 10 millennia. A journey from one end of our galaxy to the other, at the maximum speed nature allows, would consume 10 times the entire history of human civilization. If a crew of astronauts left Earth today toward the far side of the Milky Way at the speed of light, by the time they arrived, the Earth they knew would be buried under the dust of 100 millennia. Nations would have collapsed. The languages we speak today would have been forgotten for tens of thousands of years. Human biological evolution would continue. Perhaps the human species on Earth would have evolved into something unrecognizable. or, statistically more likely, would already be extinct. The heroes who crossed the galaxy would have no one left to report their discoveries to. The galactic empire is a fallacy, because there can be no empire without communication, and communication at the speed of light is too slow to keep any society united. A king on Earth would give an order, and his subjects on the other side of the galaxy would only receive the message 100,000 years later, when the king, his kingdom, and his memory had already turned to dust. However, reality is even more cruel. Building a ship that travels at the speed of light is physically impossible for any object that has mass. The energy required to accelerate a single ship carrying human beings to the speed of light would exceed all the energy contained in the entire universe. So, we have to be more realistic. The most optimistic scenario, using hard science fiction technologies that do not violate the laws of physics, such as antimatter engines or advanced nuclear fusion propulsion, suggests that one day we might travel at 10% of the speed of light. It would be an extraordinary achievement, but it brings dark math. At 10% of the speed of light, crossing the Milky Way would take 1 million years. This forces us to confront the concept of generation ships. Since the journey would last 1 million years, no astronaut would live to see its end. We would have to build a vessel that functions like a flying city, a closed ecosystem. We would lock thousands of people inside. Generations would be born, grow old, and die within dark metal corridors. Their children would have children, who would have children, and so on, for hundreds of thousands of generations. But here lies the true biological and psychological horror of crossing the galaxy. Evolution does not stop. 1 million years is enough time for a species to change completely. The inhabitants of that ship would live under artificial gravity, isolated from any other genetic mixing, breathing recycled air, and subjected to constant cosmic radiation that would inevitably cause mutations over the millennia. After 10,000 years, they would have already forgotten the language their founders spoke. English, Spanish, or Mandarin would be dead languages, replaced by new dialects born inside the ship. After 100,000 years, the very history of Earth, the blue continents, the oceans, the yellow sun, would become nothing more than myth, a distorted religion told by priests on the engineering decks. When the ship finally completed its million-year journey and reached its destination on the other side of the galaxy, the beings who stepped out would not be human. Adaptation to the closed environment, genetic changes, and the cultural abyss would have created an entirely new species, perhaps pale, with different bones and minds alien by our standards. We would not be colonizing the Milky Way. We would be building a flying sarcophagus, placing a human seed inside, and letting it germinate in the darkness for 1 million years, until something that is not us emerged on the other side. And this is where we reach the most staggering point of our journey, the terrible detail that space exploration stories always forget to mention, the great hidden obstacle. There is a plot twist in the mechanics of the universe. We tend to look at the stars and treat them as fixed points, motionless islands in a black ocean. But the universe is not static. Everything is moving at terrifying speeds. The Milky Way is a spinning disk. It rotates in a chaotic and relentless cosmic ballet. Our own solar system is orbiting the galactic center at nearly 800,000 kilometers per hour. Other stars are also racing along in their own complex orbital paths. On top of that, stars are not eternal. They are born in nebular nurseries, burn their fuel over ages, and eventually die. Some fade quietly. Others explode with the fury of billions of nuclear bombs in events called supernovae, wiping out any planetary system around them. This creates an insurmountable logistical problem for long-distance travel. Light has a speed limit. When we take our most powerful telescopes and look at a star system 80,000 light-years away, on the opposite side of the galaxy, we are not seeing that system as it is today. We are seeing it as it was 80,000 years ago. The light reaching our eyes today began its journey when Neanderthals were still walking the Earth. We are literally looking at ghosts. If our descendants point their mega-generation ship toward that star system and begin traveling for 1 million years, they are not traveling toward a physical location. They are traveling toward a very old photograph. During the million years it takes the ship to arrive, the galaxy will keep rotating. That target star will no longer be at that coordinate. It will have traveled millions of kilometers in another direction. And worse, it may not even exist anymore. It may have exploded 500,000 years ago, and the light from that explosion simply hasn't had time to reach the ship to warn the travelers. Crossing our galaxy is like trying to hit a target you cannot truly see, that is moving at hundreds of thousands of kilometers per hour, based on information that is tens of thousands of years outdated. It is firing into the dark while blindfolded, and hoping that after 1 million years of blind flight, there will be a habitable planet exactly where your mathematical model, created by ancestors long turned to dust, predicted it would be. This brings us to a very deep and heavy philosophical reflection about our place in the cosmos. It is the coldest and most realistic answer to the famous Fermi paradox, the question of where all the aliens are. If the universe is so vast and so old, why have we never seen anyone? The The answer may be that the universe has established a perfect and inviolable quarantine mechanism. The laws of physics, specifically the limit of the speed of light and the absurd expansion of space, suggest that intelligent life was not meant to mix. Perhaps right now, thousands of civilizations are flourishing in the Milky Way. Peaceful civilizations, warrior civilizations, stellar philosophers and engineers. But they are all, just like us, locked inside their own bubbles of space and time. The distances are so absurdly gigantic that they function as massive filters of isolation. Each civilization is a microscopic island in an infinite archipelago. We might even build tall bonfires and use our telescopes to see the light of other islands' fires faintly glowing on the dark horizon. We may know we are not alone in the mathematical sense, but the water between our islands is dark, lethal, and fundamentally too vast. Our biology is too fragile, our lives are too short, and light itself is too slow to allow us to build bridges one day. Crossing our galaxy is not a matter of discovering a new type of fuel or building a stronger hull. It is a matter of confronting our own mortality and our insignificant size before the merciless vastness of creation. And the harsh astronomical reality points to a fact that fills us with both melancholy and deep reverence. We will probably begin and end our entire journey right here. The stars shining in the night sky are not tourist destinations waiting for our arrival. They are silent reminders of an impassable ocean, too beautiful not to observe, but too distant to touch. If isolation is our destiny, then it is up to us to make this one island we have worth it. What do you think? Is the universe's cosmic quarantine a curse that imprisons humanity, or a blessing that protects us from things we are not yet ready to understand? Leave your opinion in the comments. Subscribe to the channel so we can keep uncovering the hard truths of the cosmos, and I'll see you in the next video.